We are going to solve questions using K-maps, but first of all, we are going to start with min terms. Okay, so instead of doing random questions, I'm going to teach you an important question that most of the times that come to the exams, that comes to the exams, and it's a little bit tricky too. Okay, so here the question is, we are going to find a specific logic gate system. Okay, we are going to draw a logic gate solution where 4-bit numbers that range from 0 to 15 are supplied. Okay, so what do I mean by 0 to 15? Well, think about it. Let's say we have the decimal numbers from 0 to 15. Okay, and these can be specifically converted to 4-bit numbers, right? 4-bit numbers, because we know 2 to the power 4 is equals to 16. So when we use 4 bits number system, there can be 16 numbers created. And these 16 numbers can be specifically designated from 0 to 15 in decimal number system. This is how it works. So that is what represented through ABCD 4 bits. Okay, so 0 is represented by 0000, 1 is represented by 0001, or if you think about 9, it can be represented as 1001. So if you think about it, it's just the decimal number converted to binary, but it uses a 4 digit number system, 4 binary digit number system, 4 bit number system. And what are we trying to find here? Well, this truth table, the truth table given here, actually actually verifies if a number is a prime number. Okay, we know what a prime number is, right? Any number with only two factors. Okay, two factors. So in between 0 and 15, the prime numbers are 2, 3, 5, 7, not 9. We have 11 and then 30. So these inputs should output 1. Okay, so these inputs should output 1 and the other inputs should not output 1, or they should output 0. Okay, so if you look at this, 2 corresponds to output 1, 3 corresponds to output 1, 5 corresponds to output 1, 7 corresponds to output 1, and 11 and 30. Okay, so there are only 6 outputs that produce 1. Okay, that produce 6 inputs that produce 1 as output. This is what we have in our hands. So how can we use this data? Okay, so they have given us the truth table, which means we can find the min terms, which we have already studied. But how can we use k-maps for simplification? That's why we are learning about k-maps, right? Simplification of Boolean expressions. So first of all, if we have to expression simplify an expression, we need an expression. And that is why we have this guy. So let's find out all the min terms. Okay, so this is the min term 3. Yeah, this is the min term 2 actually, because this is m0, this is m1, so this is m2. Okay, we can name it as m2 for our easiness. Okay, and this can be given as m3. Okay, and this can be given as m5, and this is m7, m8, m9, m10, m11, and finally we have m30. And this is equals to, in min terms, talking in min terms, we know zeros are absent terms and ones are present terms. So it can be given as a bar, b bar, c, d bar, and m3 can be given as a bar, b bar, c, d, and m5 can be given as a bar, b, c bar, d, and m7 can be given as a bar, b, c, d, m11 can be given as a and then b bar, c, d, and m13 can be given as a, b, c bar, d. So we know if can be given as. Okay, so first we are finding the Boolean expression, aren't we? We are finding the Boolean expression. So the Boolean expression for prime numbers, verifying prime numbers, in between the numbers 0, from the number from 0 to 15. Okay, so Boolean expression f. Okay, Boolean expression f is equals to a bar b bar c d bar plus a bar b bar c d plus a bar b c bar d plus a bar b c d plus a b bar c d plus a b c bar d. All right. This is the Boolean expression. That's it. We don't need the truth table anymore. We don't need the truth table anymore. We just need the Boolean expression. If you start simplifying this Boolean expression by using the Boolean algebra rules that we have studied, okay, the 3i, 3d, and car rules, you won't be able to finish it on time. That's why we use K-maps. Okay. Now I'm going to teach you how to convert a Boolean expression into a K-map. That is what we are going to study now. Okay. Since there are 4 inputs, we need 16 cells. Okay. Each input corresponds to a specific cell. Each input corresponds to specific cell. If you look at the last video, I told you I will be teaching you how to convert truth tables into K-maps. That is the focus of this video also. And in the last video, I also told you there are multiple ways of drawing K-maps. Okay, there are multiple ways of drawing K-maps. And that's what we are going to focus now. Before we jump directly into 4-input system, we will go into 2-input system, 3-input system first to make the waters safe for us. Okay. So let's say we have a 3-input system. Okay. So let's say we have an input system called ABC. 2-input system. Let's say AB only first. Since there are only 2 inputs, there are how many inputs? 2 inputs. That means we have 4 possible combinations. We know that because 2 to the power 2 is equals to 4. So there are 4 possible combinations for inputs. Then the K-map also should have 4 cells. The K-map also should have 4 cells. K-map should also have 4 cells. And how do we assign these cells for different combinations? Well, first of all, since you have only A and B, you can put A here, B here, or you can put vice versa. It doesn't matter. The order really doesn't matter. Okay. And A and B are there. You can clearly see A and B are there. Here, we will say A is absent, A is present. We will say B is absent, B is present. In 2-input systems, okay, if you have a 2-input system, have a 2-input system, you don't have to worry about the order of the absent or present also. You can just draw like this. So if let's say in a 2-input system, there are 4 possible combinations. What are they? A bar, B bar, A, B bar, and then we A bar, B. Let me erase this. Yeah, A bar, B, and then we have A, B bar, and finally we have AB. These are the possible 4 combinations, right? So to mention A bar, B bar, you will put a 1 here. Since we are talking about min terms, for now we are solving using only min terms. In the next video, we will talk about max terms. But in max terms, I won't go 2 inputs, 3 inputs, 4 inputs. I will directly use it for 4 inputs. So learn the basic concept here, how we are corresponding things. A bar, B bar corresponds to this cell. Why? A bar is this vertical line. B bar is this vertical line. And they both intercept at this specific cell. That's why we put 1 here. Okay, you can imagine like that. Okay, or you can think of it like finding Cartesian plane. Like think of it as a Cartesian plane, right? If you have a Cartesian plane, okay, or graph, we have x-axis and then y-axis. If they ask you to mark 3, 5, okay, if they ask you to mark 3, 5, you will go 1, 2, 3, 3 units in x direction, and then you will go 5 units in y direction. Then you will mark the point that is intercepting both these lines, right? This is the vertical line, this is the horizontal line that represents, this is the line that represents y is equals to 5. If I draw a line, it will represent y is equals to 5. And if I draw a vertical line, it will represent x is equals to 3. And the intersection of these two lines will be 3 comma 5. That's how we mark a plot graph, right? That's how we plot graph. Similarly, here a bar b bar can be plotted as 1 here. That corresponds to this specific cell corresponds to a bar b bar. If it is present, if the min term is present in the expression, you will mark here. Similarly, we have a bar b. Well then, a bar b, you can put the 1 here. Or if we have a b bar, you will put it here, put the 1 here. Or if it is a b, you will put the 1 here. This is how we work for K-maps. This is how we work with 2 bits input systems, okay, and convert it into K-map. Now let's go to 3-bit systems. Okay, so let's say we have A, B, C. The name of the input doesn't matter, right? We already know, so don't worry about that. Since we have 3 inputs, the number of combinations for inputs will be 8, because 2 to the power 3 is equals to 8, which means we need 8 cells. Okay, we need 8 cells. And as I taught you in the first video itself, okay, in the previous video, I taught you that only squares and rectangles are allowed in K-maps. So if you need 8, you can either have 2 by 4 or you can have 4 by 2. It doesn't matter in which direction you are drawing, but it should be 2 by 4 or 4 by 2. Let's draw 2 by 4 first. So we have 8 cells. Now we have to name the directions. Okay, we have to name the directions. Since we have 3 inputs, you can either put A, B, C. The A, B should come where you have the most cells. Row wise, if you think about it, there are 4 columns here. Okay, there are 4 columns here. That's why you put AB here. If you had drawn this in the opposite direction, like 4 by 2, okay, if you had drawn the K map like this, 4 by 2, then the naming of the direction will also change, because we have 4 rows here. Okay, we have 4 rows here. So we will go like this: AB here and C here. Does that matter actually? AB, does that matter? Should it be AB? No. You can put AC and B also if you need. You can put AC and B, or you can put ABC. It really doesn't matter how you are putting how you are naming the direction. The order of the inputs doesn't matter actually. But for our easiness, what we have to do is we normally name it in the proper order. Now, since we have 8 input combinations, let's name them all. So we have A bar, B bar, C, and then we have A bar, B bar, C bar, then A bar, B bar, C, and it goes, right? A bar, B, C bar, A bar, B, C, A, B bar, C bar, A, B bar, C, A, B, C bar, A, B, C. These are the 8 input combinations that we have for 3 input system. How do these cells correspond? Well, first of all, I'm going to teach you how to write the order first. So since you have AB, okay, you have to write 4 combinations. Okay, if it's a single input, we had only 2 combinations, A bar and A. Since we have AB here, we need 4 combinations. But the order is a little bit odd compared to truth table. In K-maps, the order is a little bit odd. Okay, so that is very important thing to remember. Why is it important? Well, normally what do we do? When we are writing an order, we will say A bar B bar, and then we will say A bar B, then we will have A B bar, and finally we will have AB. This is the normal order. But this doesn't work with K-map. Okay? K-map has a specific order. Okay? So it doesn't matter where you start. You can start wherever you want. But conventionally, we start with A bar, B bar. Now, you have to be careful. Since both are absent in the first column, the second column must have at least one of them active or present. You can either write AB bar or you can write A bar B. This is a must. If both are not active, the second column must have one of them active. Then, since B bar and B are here, okay, here B is absent, right? That's the meaning. B bar means B is absent. Here B is absent. Here B is present. If you consider this, here also B should be present. That's the order. Here also B should be present. And finally, B can be absent here. And here, if you think about it, A is absent here, A is absent here. Then A should be present here, A should be present here. How does this pattern work? Okay, this pattern is very simple. It should be the inputs, right? The single inputs, they should be present consecutively in two columns and then absent consecutively in two columns. That's the idea. Okay, now you may ask, but B here is consecutively present, but here it is absent and here it is absent. If you go to the previous video, I taught you that wrapping around is an option in K-map. So if you wrap around this table, this B bar and this B bar will be connected to each other. Okay, so that's why when you're drawing, you should be careful about that. See, A bar, B bar, A bar, B, this one is AB. Instead of A, B bar, we have AB. Then we have AB bar. Okay, similarly, if I try BC here, instead of putting A bar, B bar, C bar, let's say I'm putting B bar, C starting. We are starting with B bar, C. Well, then, since this is absent and this is present, you have to choose which one you are going to alternate. So here B is absent, C is present. Either this should be C or this should be B absent or B bar. So you can choose it like this. B bar, if you choose B bar, this should also be absent. C bar. Okay, B bar and C bar. Okay, then since we have B bar, these last two should be B. And since here we have C bar, we have to put C bar here and C here. So it will be B, C bar, and finally we have BC. This is how you have to write the inputs in order. For K-map. Okay, so you have to try it in your free time, or else you will forget this. Okay, there is a high chance you might forget this. Then, since this is just one input, this C bar C or C bar, it doesn't matter. Let's just put C bar C here and here A bar A. It doesn't matter. Now we are going to connect these. Okay, As I taught you in the previous example, you just have to find the direction. So here we have A bar, B bar and C bar. So it corresponds to this guy. Okay, and if you want to select this guy, A bar, B bar, C, it will be this cell. And let's go here also. A bar, B bar, C bar. So we have A bar, B bar, C bar here. So the one will be put here. Okay, and for A bar, B bar, C, we have A bar, B bar here, but C we need. So A bar, B bar, C, we have to put the one here. Okay, well, let's say we have to put A, B bar, C in both of this. Well, we have A here, B bar here, so C here, and this is the one. Here we have A here and B bar C here, so the one will come here. This is how you have to mark for 3 inputs system. Now we are going to 4 input system. Okay, now this is interesting because here we have 2 to the power 4, right? Here we have 2 to the power 4, which means 16 blocks. Now 16 is a problematic block. You can either give it as 4 by 4 or you can give it as 2 by 8 or 8 by 2. This also creates a square. This creates a square. This creates a rectangle. This creates a rectangle. Which one are you going to choose? Well, conventionally, we choose this. Conventionally, we choose this. But does it matter if you choose 2 by 8 or 8 by 2? Not really. No. But conventionally, we choose 4 by 4 for questions because it's easier to draw. So that's what we are going to do. So we have 4 rows and 4 columns. So let me draw that first. Let me draw the K map. So we have 1, 2, 3, and 4. Now we can name the directions as AB and then CD. Now we have to order this, right? We have to put the combinations in order. We'll start with A bar, B bar, and the next one should be either it should be A bar B or it should be A B bar. So we'll use A bar B. Now we have A bar and A bar here, so it should be A and A here. Here we have B bar and B, so it should be B and B bar. Similarly for CD also. So C bar D bar, C bar D, and then we will have CD bar, and finally CD, and then finally we will have CD bar. Okay, CD bar. So here we have C bar, C bar, C, C, D bar, D, D, D bar, A bar, A bar, A, A, B bar, B, B, B bar. Okay. Now we have to mark the minterms, the corresponding minterms. So we have A bar, B bar, C, D bar, A bar, B bar, C, D bar. So it should come here. And we have A bar, B bar, C, D. So it should come here. And then we have A bar, B, C bar, D bar, C bar, D. So A bar, B is here in this direction. C bar, D is in this direction. So one comes here. And then A bar, B, C, D. Okay. A bar, B, C, D. So it comes here. And A, B bar, C, D. Okay. A, B bar, C, D. A, B bar is here. C, D is here. And then we have A, B, C bar, D. A, B, C bar, D. That's it. This is how you have to mark the ones. Now, how do we simplify? So the second step is done. We have converted the Boolean expression into K-map. Now we are going to simplify. How are we going to do that? Well, let's do that. Let me copy this completely, okay, and put it here. So this is the second step, converting the Boolean expression into a K-map. That is done. That is done. Now, the next step is we are going to simplify this. Okay, to simplify this, we use grouping method. Okay, we use grouping method. How does grouping work? Well, it's simple. I already taught you in the earlier video also. There are some rules you should follow. Okay, you have to group the ones in the groups of 2 to the power numbers. Okay, 2 to the power numbers. That means you can have 2 to the power 0, you can have 2 to the power 1, you can have 2 to the power 2, or you can have 2 to the power 3, and finally 2 to the power 4. If you are choosing 2 to the power 4 grouping in a 4 bit input system, that means every input corresponds to 1. Okay, so this will never happen practically. Theoretically it might happen, but practically it won't. And this means there is a group of 8. Okay, there is a group of 8. Okay, so this happening also, the possibility of this happening also very rare, but these can happen. Grouping of ones, grouping of twos, grouping of fours can happen, and that's what we are going to do. And if you see here, I can group these two, 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 and finally I can group this one with this guy. Okay, I'm wrapping around. The previous video I have gone through all of these rules. Okay, so we are going to group in chunks of 2 to the power numbers. Okay, 2 to the power numbers. And since we don't have other ways like 4 or 8 or 16, we have to only group using twos. Okay, groups of twos, and we have to cover every single ones on the plane. Okay, on the K map, and that we have done. So there are totally 4 groups. Okay, this is the first group, this is the second group, this is the third group. Okay, 1 2 3, there are 5 groups. This is the fourth group, and finally this is the fifth group. Okay, And now you are going to simplify this and write it down. Okay, you are going to simplify this and write it down, how it works. So f is the output, right? F is the output. So how does grouped um, grouped items work in K-map? How does they translate into an expression? Well, that's a good question. So if you think about it, A bar, B bar, this is in the column direction, right? In the column direction. Okay, in the columns direction. So A bar, B bar is present in both of them. In this group, if you consider the group 1, okay, if you consider group 1, A bar and B bar are present in both. The both units contain A bar and B bar. So you will write it down, A bar and B bar. You won't change anything. But here, if you consider row wise, C is present in both of them. Okay, C is present in both of them. But D and D bar are only present in both of them. Which means D and D bar will cancel out each other. D and D bar will cancel out each other. That's how you have to think. They will cancel out each other. So you will get A bar, B bar and C. A bar, B bar is present in both units in the grouping 1. C is also present in both units of grouping 1. But D and D bar are present. So D and D bar cancel out each other. So you will get simplified A bar, B bar, C. You will get A bar, B bar, C. Similarly, if you think for second group, okay, if you think about row wise, think it about in the row section, C, D are present. Okay, C and D are present. But if you think about in the column wise, okay, A bar is present in both of them, but B and B bar are present. B bar and B are present. So they cancel out each other. Similarly for the third one. Okay, similarly for the third one. If you consider column wise, A bar, B is present. But if you think about it in row wise, D is present, but C bar and C are present, so they cancel out each other, so only D will come. Similarly for fourth one, if you think about it in the column wise, A bar and A are present, so A will cancel out each other, so B is present. And then we have C bar D, so we'll put C bar D here. And the fifth one, it may look tricky, but it's really not. We have A, B bar, A bar, B bar. Okay, we have A, B bar, A bar, B bar. B bar is present in both of them. A and A bar are present in the grouping. So they cancel out each other. A bar and A will cancel out each other. So you will get B bar. And then row wise is just CD. So you'll put CD here. So F will be equals to A bar, B bar, C plus A bar, CD plus A bar, BD plus B, C bar, D plus B bar, CD. Okay. Yeah, B bar, CD. Perfect. That's it. And yeah, this is how you do it. We have simplified it by using K-maps. Now, this is the application of K-map. That's it. Simplification is done. Now you can draw the block diagram, and then you can go into drawing the logic circuits using logic gates, and you can draw using NAND gates and NOR gates that I have taught in the previous videos. Please go through them if you want to, but this is the simplification of this specific question. Simplification of this specific question is as given here. Thanks for watching the 28th video in our logic gate series. If you found this guide to simplifying Boolean expressions by using K-maps helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos. I'll meet you in another video. Until then, keep learning and stay curious.